everyone. Today we have a wonderful speaker with an amazing topic that we all need to know more about. And this event is the second event in the series, Sustainability Seminar Series. And your host is Iman Al-Haji, a PhD student in Material Science and Engineering, innovating nanocarbon materials and energy storage at KAUST. Hello, everyone. So today we're so honored to have Dr. Heather MacLean with us today from the University of Toronto. Professor Heather MacLean is the Canada Research Chair in Sustainable Systems and Technology Assessment and a professor of the Department of Civil Engineering, and holds joint appointments in the Department of Chemical Engineering and Applied Chemistry and the School of Public Policy and Governance at the University of Toronto, Canada. Professor MacLean's expertise is in the development and applications of life cycle assessments, approaches for the techno-economic and environmental evaluation of conventional alternative energy systems. Over the past 15 years, she has worked closely with the automotive, oil, electricity, and biofuel industries, as well as federal and provincial, state, and governments. She has served on the industry and government advisory committees in both Canada and the US. Her research has informed the development of energy and environment policy in Canada and in the US. Professor MacLean was recently awarded the Canadian Mortgages and Housing Corporation Excellence in Education Award for promotion of sustainable practices. She has a PhD in Civil Engineering and Engineering Public Policy from Carnegie Mellon University. Warm welcome to Professor Heather MacLean. We're so honored to have you today, and the floor is yours.
Thank you, Iman, for the kind introduction. I'm very pleased to be here. Good evening to everyone, or good morning, or good afternoon, wherever you may be. And thank you very much for this invitation. It's a pleasure to present today. And I'm presenting on a topic that I'm passionate about. It's exciting for me to be part of the journey from the relatively early stages of life cycle assessment in the late 1990s, which seems not that long ago, but is a long time ago, to today, and to see how the field has grown, advanced, and expanded. So during my talk, I've sort of framed my presentation as follows. I'm going to introduce greenwashing, although most of you will be familiar with it, talk about life cycle assessment, then discuss the relationship between greenwashing and life cycle assessment, and provide some examples from research and other literature, my research and other literature. And I'm going to conclude with some perspectives on the utility and challenges of doing rigorous LCA. The examples in my talk will mainly be focusing on climate change and greenhouse gas emissions, but I'd like to acknowledge the other environmental impacts, and I will talk about them as I go through. So let's start. When looking at comparing products and whether one is better for the environment, this isn't a simple task. For some of the common examples here, there have been many studies, sometimes coming up with conflicting results. And the nature of these studies has brought to the forefront the importance of looking at the details of these studies. For example, are plastic or paper bags better for the environment? Is one always better for the environment? Are you sure? What about electric or gasoline cars? Electric cars don't have tailpipe emissions, but what about the source of the electricity or how the batteries are produced? What about bioplastic or conventional plastics? Are renewable products always better for the environment? Clearly not the case. And what about hand dryers or paper towels? Does it matter what type of dryer, what type of electricity, and how many paper towels you're using? So the answer is that it depends. And it's even a simple product like bags. The complex and analysis are complex and depend on many factors. Will the reusable plastic bag actually be reused? And which environmental impacts are we considering? What about trade-offs between water pollution and air pollution? or the variability of facilities and production processes for each product. The best facility is often much, much better from a productivity point of view than the worst facility. So we're going to explore some of these things during the talk and also bring in some other examples. But first, I'll introduce greenwashing. And most of you are familiar with this, but greenwashing is when firms mislead consumers about the environmental performance or environmental benefits of a product. There's increasing stakeholder pressure on companies to disclose environmental performance of their products. In 1986, activist Jay Westerfeld sort of coined the term of greenwashing, where he commented about hotels forcing guests or suggesting to guests to reuse the towels to conserve water. But he felt that this was greenwashing because there weren't actions that had more significant environmental impacts. So they weren't focusing some of the other aspects of their service that should be a focus for greening their products. Greenwashing also can come in many different forms. So we have to be aware that it's not just a claim. It could be a color that's used on the packaging of a product, or a symbol. Perhaps the symbol indicates or suggests to indicate that a product has gone through some type of process, a green certification process, but maybe it hasn't. And these forms create the impression that the product is greener than it really is. In 2007, TerraChoice, which has been acquired by UL, launched a study of environmental claims made on products carried on leading big box store shelves. They came up with the 7 sins of greenwashing to help consumers identify products that made misleading environmental claims. I'm not going to go through these in great detail. Most of them are fairly obvious, but I will come back to these and relate each of these 7 sins to life cycle assessment near the end of my talk. So I'll just introduce something like the hidden trade-off. This is a claim that a product is green based on a narrow set of attributes, but not paying attention to other potentially important environmental issues. No proof is when the environmental claim, can't be substantiated by easily accessible, supporting, or reliable third-party information. And most of the other ones are fairly obvious. So how prominent is greenwashing? There was a global sweep by the International Consumer Protection and Enforcement Network that found, I believe in 2021, that about 40% of firms' green claims online could be misleading consumers. So not saying they were, but they could be misleading consumers. And what they found was that these fit generally within those 7 sins of greenwashing. Vague claims and unclear language without any evidence, own brand eco-labels and logos, and selective disclosure kind of aspects like hiding or omitting info to appear for the product to appear more and eco-friendly. Now, generally, governments have been taking some action in recent years, and usually the marketing or consumer authorities are those sections of government aiming at greenwashing. So just providing a couple of examples. There are many others globally. There are some in Canada, but I selected the Danish and UK examples because they seemed some of the more prominent ones. So the Danish Marketing Practices Act, and I'm going to focus here on, there's other aspects of it about deceptive marketing. So in general, it's that deceptive marketing is if a product does not conform to the marketing. And so the greenwashing is one aspect of deceptive marketing. But here, I'm just going to focus on the aspects that are most specific to LCA. So under the Danish Marketing Practices Act, they require that a full life cycle assessment is required as supportive statements about a product being environmentally friendly. There's also the UK Competition and Markets Authority, and this is UK's primary competition and consumer authority. And the CMA, as they're called, uses its consumer protection laws to protect consumers from unfair business practices and unfair contract terms. In 2021, they put out, the Competition and Markets Authority put out the Green Claims Code. And amongst those claims were that claims about a product must be truthful and accurate, clear and unambiguous, not omit relevant information, so no selective disclosure, and as well, in alignment with the Danish Marketing Practices Act, they required that a full life cycle of the product must be required. So both of these point to the need for life cycle assessment to back up marketing claims and green marketing claims. So now let's go into life cycle assessment. Many of you are probably familiar with life cycle assessment, whether you've been using it in your research or you've read a life cycle assessment or just heard the term in the news. Life cycle assessment is a technique that quantifies environmental impacts of a product throughout its entire life cycle. As you can see here in the figure, most products start with the raw materials, extraction from the earth, the manufacturing of components and parts, and the product itself. Their transportation steps are included in a life cycle assessment, whether by air, water, rail, truck, the retail aspects or the use of a product as well. So in the case of a motor vehicle running on gasoline, the vast majority of impacts come in the use stage, the disposal of the product, and then any type of end of life aspects. Key here to note is that life cycle assessment should not be confused with a life cycle costing study. It does not include any aspects that are economic. It does not look at the cost of the product, only the environmental impact. It is important to remember at the outset here that all products have impacts on the environment. Any product that is produced throughout the production stage has impacts on the environment. Even if a product has no impacts generally throughout its lifetime, it will have impacts on the environment in its production and its disposal. So there's no product that has no impacts on the environment. It's also very difficult and complex to identify or verify a true green claim. And that's one of the challenges with the concept of greenwashing. Briefly, I'm going to talk very briefly really about some uses of life cycle assessment just to set the stage. So traditionally, life cycle assessment was utilized to examine products, to inform product development, to inform policy. It's more recently been used more in marketing, and this is where greenwashing comes into play, and also used in comparing products. Portions of products, like should we use aluminum or steel for part of our vehicle, or comparisons of natural gas versus coal, electricity from different sources, electric versus gasoline vehicles. Governments, companies, consultants, academics, and research institutions all use and do life cycle assessments. More recent uses are in the enforcement of policies. So over the last decade or more, the California Air Resources Board has had their low carbon fuel standard, where this standard is based on fuels, transportation fuels must achieve a certain carbon intensity, greenhouse gas emissions intensity on a per megajoule basis in order to be sold within the state. All those selling within the state must reduce their carbon intensity over time. And so the enforcement of the policy, it's not just the informing of the policy, but the actual enforcement is based on a life cycle assessment, which brings into it a lot of complications, but it has been successfully implemented. And there are other low carbon fuel standards in other jurisdictions around the world. Also more recently, it's been required of those developing new technologies or other to have a life cycle assessment done of their technology in order to get funding, whether from government or venture capital or other. So it's become increasingly critical to have accurate life cycle assessments. Life cycle assessment is useful to manufacturers and researchers seeking to improve processes, also consumers looking to buy greener products, and then policymakers aiming to set environmental targets. What constitutes an LCA? There is a standardized process for life cycle assessment. These standards fall under the International Organization for Standardization, or ISO, and fall under the environmental management portion of those standards. There are two standards. The first one, ISO 1440, is regarding the principles and framework, and I'll talk about the framework in one moment, for LCA, and then more detail about requirements and guidelines for LCA are in the second standard, ISO 1444. These standards are important as they provide guidance to researchers or others doing LCAs. They provide a common language surrounding elements of LCA studies. They lead to enhanced comparability of results of LCA studies and also a reduced potential for the manipulation of life cycle assessment outcomes. But I will note on the other side that there is much room for subjective aspects and modeling decisions and selection of data to be made by those conducting an LCA. So one of the key aspects I always emphasize for life cycle assessment is that the documentation must be complete and all aspects should be transparent. And this is very challenging because of the amounts of data and number of assumptions that must be made in LCA studies. So the LCA framework under the ISO standard consists of 4 components. Firstly, the goal and scope definition, the life cycle inventory analysis, and the life cycle impact assessment, followed by the interpretation stage. Not all life cycle studies end at a life cycle impact assessment and include that stage. Some studies may only go to the inventory analysis, and then the interpretation is done on the inventory, and I'll describe the steps subsequently. First is the goal and scope definition. And this states the intended application, reasons for the study, the intended audience, and then of particular importance for the greenwashing topic is whether the results are intended to be disclosed to the public by a company, for example, in comparing their product with another one or with an average industry metric. Essentially, the goal says who might care about our study and why? Why did we do it? And what will we do with the study? So there are additional requirements when a company wants to use a life cycle assessment study results in support of a green claim about their product. And I will cover those later in the talk. The other components of the life cycle assessment are the inventory analysis, the impact assessment, and the interpretation. So the inventory is essentially the inputs and outputs, the quantities of physical inputs and outputs, materials going in and emissions coming out or waste coming out of each unit process. And these must be tracked throughout the entire LCA. And the ones of the inventory that will be tracked are going to be defined under the goal and scope definition. Then those inventory quantities are compiled into categories for various environmental impacts. And this will be described later. And then interpretation is the results of the inventory analysis and the impact assessment are interpreted in relation to the objectives of the study. So each of these 4 stages of the life cycle assessment is critical to follow and the procedures under the ISO guidelines. Life cycle assessment is complex with many steps and details of the method. While the math involved is easy, addition, subtraction, multiplying, and dividing, the concepts are not always straightforward, and a good study may takes many months and sometimes years to complete. This slide is meant to highlight a few of the key aspects of life cycle assessment that I'm going to use sort of as a roadmap to discuss in the next section of the presentation. Under the goal and scope definition, some of the critical aspects are the product system, functional unit, system boundary, impact assessment, and the data that are needed, which are considerable. Under the inventory analysis, how co-products are treated is very critical and can really affect results. As well, any good LCA study should include variability and uncertainty analysis, explicit analysis, and not just be point estimates. In spite of this guidance to practitioners, many LCA studies still fall into the trap of best estimates without appropriate treatment of variability and uncertainty, and can result in misleading insights. Also, it's important to think of what products do we compare and how do we make sure that it's an apples to apples comparison. So starting with the functional unit, which is one of the most critical aspects of life cycle assessment. It is defined within the goal and scope. The functional unit represents the function of the product or system and must have units associated with it. They don't necessarily need to be SI units. It could be something like one pair of dried hands if you're comparing paper towels and a hand dryer. But it must be related to the function of the system and quantifiable and have units. All raw data in the study, so all of the inventory aspects, the energy, resources, emissions, wastes are normalized to the functional unit. So if we were comparing plastic and glass bottles, maybe we'd look at one 500 milliliter bottle of water as our functional unit, and we'd report our emissions. For example, we might say number of kilograms of CO2 equivalent greenhouse gas emissions per 1 milliliter, one 500 milliliter bottle of water. Comparing a bus versus car transport, maybe we'd look at one passenger kilometer traveled. And maybe when comparing paper towels and hand dryers, we'd look at one pair of dry hands. Results of studies can look very different depending on the functional unit selected. And sometimes the product that is shown to be greener changes depending on the functional unit selected. So this is an important component of a study. And sometimes, as in some of my past work, I've looked at multiple functional units to see whether the result changes. Moving on to the goal and scope on the system boundary. Depending on the objective of the study, different phases can be considered. These include the cradle to gate, which looks at raw materials extraction, up to, in this case, the vehicle manufacturer, so the gate of that facility that manufactures the vehicle. You can have also cradle to grave, raw material extraction to the product's end of life, and then cradle to cradle, similar to cradle to grave, but focus on a process that aims to reuse the waste. This gives a bit more detail and shows the data requirements essentially for the production and use of corn ethanol, which is a biofuel that can be used and blended with gasoline in vehicles. While this doesn't include all of the supply chains, for example, up on the left side, it's a little bit small, but you can see there would be fertilizer manufacturing. So you would need to look at all of the supply chain for the fertilizer production, which would be encompassed by this individual box here. So you can quickly see that a lot of data, even for this relatively basic product of the ethanol, is required for the study. And also it's noted that you need to take into account not just fossil fuel inputs, but in the case of a biofuel, you have biogenic inputs where you have soil carbon release due to growth of the corn. You also have carbon sequestered to the soil as the plant grows. So biogenic carbon accounting is a complexity of LCA. In the life cycle inventory analysis, this is where you're going to be collecting all of your data. It's defined by the goal of the study. The data is collected and quantified, the inputs and outputs of the product system for all of the unit processes within the system. The data for each process is tallied up in different categories. And this is often, the data collection is often the most challenging part of an LCA. For each step along the process or supply chain for each unit processes, you need all of the inputs and outputs. LCA is directly dependent on the quality of the data used in the inventory analysis, and good data are hard to find. Even with life cycle assessment software, It's very critical still to examine in detail that software and the assumptions, the data in it, and determine if they're appropriate for your analysis. And no study can ever collect all primary data, so you will be reliant on secondary data for your LCA, along with the primary data that you've collected on your specific process. So sometimes, past years, you could get bogged down in too much paperwork or too many files on the computer at this point. Not going to go through this in detail, but just to say that there are a lot of steps in the life cycle inventory analysis, and I'm glossing over them here. But to give you an idea of the steps, here is the figure from ISO 1444, which talks about the data collection through the data aggregation steps of the LCA. Co-products, as I mentioned earlier, are something that has to be dealt with in LCA. Almost all systems produce more than one product. This also applies to the treatment of a waste input to a process, which is a multiple product of another system. And under ISO, there is a hierarchy of methods for co-product treatment from the most to least preferred, and they're shown on this slide. First would be to disaggregate the product system, to separate it and determine what aspects of the unit process produce product A versus B versus C. I've never seen a study actually able to do this. It's not commonly used in practice. System expansion is where you redefine the system to avoid allocation. I'm going to give an example of that later. And you end up giving a credit to the main product that you're producing, because you're no longer having to produce products B and C from another source. And so you give a credit associated with that. It's a fairly straightforward to explain, but not always easy in practice. And then there's the allocation, which is very commonly used along with system expansion in life cycle assessments. The first one is always to do it based on underlying physical relationship, and then economic value can be another way to do it. The life cycle impact assessment connects the inventory flows, the quantities of physical substances with the different environmental impacts. It aims at understanding and quantifying the magnitude and significance of the potential environmental impacts of a product throughout its life cycle. And the physical quantities from the inventory, for example, greenhouse gas emissions, are weighted by global warming potentials for the climate change impact. There are midpoint categories, which is characterized by environmental mechanism here. These are problem-oriented, useful to understand which environmental impacts are occurring. And then there are also endpoint categories, or damage-oriented, which help create a holistic understanding more about the overall impact. And these could include damage to human health, damage to ecosystem quality. So there are a number of life cycle assessment software tools that can be used within a study. It must be recalled that these are all front ends to databases. They aggregate and calculate the life cycle inventories and can do impact assessment. But it's critical to not consider that these are just black boxes. It's critical to dig into the details when using LCA tools. What are the sources of the data? What year were they collected? What geographical region and type of process do they apply to? Are they appropriate and match with the product and source you're considering? Is the documentation up to date and transparent and full? As I mentioned before, under ISO 1444, if a company wants to report to the public the environmental performance of their product and compare it to another in the sector or those of another company, then there are some specific requirements under the life cycle guidelines. So a life cycle impact assessment must be completed. You cannot end at just the inventory analysis. You have to have the sensitivity and uncertainty analyses. You have to examine the differences that were found within your study. And you also have to have a critical review where the following is required. So getting into greenwashing and LCA. So what's an appropriate functional unit for grocery bags? Should we look at one bag? Should we look at the number of bags to carry a volume and weight of groceries for 1 year? Our study results could be quite different depending on the results and what functional unit we've selected. So a study found that the number of times a bag must be reused to have the lower impacts in most environmental impact categories than a single-use plastic bag varied substantially depending on the type of bag that was being compared. If you looked at cotton bags, you'd have to reuse them 50 to 100 times to have lower impacts than the single-use plastic bag overall. Paper was 4 to 8 times and reusable polyethylene 5 to 10. So it showed really how important it is about the functional unit. It wouldn't be fair to compare one plastic bag and one cotton bag without consideration of number of use times. Another example shows how important the functional unit is in transport modes, where you see that in the top figure, where you're looking at kilograms of CO2 equivalent per vehicle kilometer traveled, then obviously the bus has more impacts than the car. But if you switch it to per person kilometer traveled, then the bus becomes far more efficient than the private car, as you would expect. So obviously in this case, it's quite self-explanatory, but per person kilometer traveled is a more appropriate functional unit when comparing different transport modes. This study came from some work we did in Singapore, and so is collected with actual capacities used on buses and things like that. This is a bit of a complex figure, but often when we are looking at the interest in converting carbon dioxide into usable products, whether the carbon dioxide comes from an industry source like flue gas, or whether it's a direct air capture system capturing CO2 from the air, which is the case for this example. What if we did an LCA study of the direct air capture plus a Fischer-Tropsch fuel production, and we selected a very low greenhouse gas intensity for the electricity generation, so all renewables, for example. So on the left axis here, the y-axis is the carbon intensity of the fuel on a per megajoule basis, and then on the x-axis is the electricity emissions factor. And this is in grams of CO2 equivalent per kilowatt hour. As we can see, depending on the electricity emissions factor, the results are very different for the production of the fuel. So looking at the conventional diesel bar line, and then the DAC plus FTS lines, we see that at about 140 grams of CO2 equivalent per kilowatt hour, these fuels are about the same for carbon intensity. So the CO2 option isn't lower than the conventional diesel. And when we compare with electricity grids, say the average US grid of 365 grams of CO2 equivalent per kilowatt hour, producing this fuel in the US on an average grid would end up with a higher carbon intensity than diesel. There are also lots of life cycle of databases, as I mentioned, that have life cycle inventory emissions factors in them. This example compares the differences in greenhouse gas emissions of building components. And the reference is a common database called EcoInvent. And as you can see, there's almost a 200% difference in the wood fiber board, the left-hand side in green, compared to for another major database called GABI, compared to EcoInvent. As no LCA can be based only on primary data, we must really rely on this secondary data. And we have to make sure that the products that we're modeling are accurately reflected in the database, and often use different data from different sources to really check on the accuracy of the data, underlying data we're using. In co-product treatment, if we were to allocate the emissions associated with gold to gold and the ore that's extracted at the same time that the gold is extracted from, and we did this on a mass basis, obviously this would be something that would be very misleading to do, and we'd allocate almost all of the emissions to the ore and not to the main product being the gold. Co-product treatment is a big factor in many LCA results. And here's a more specific example. The production of ethylene from corn has a co-product, which is an animal feed. It's called distillers' dried grains and solubles. And as shown in this figure, if no allocation to the co-product is done, and all the emissions are associated with the ethylene product, then the best estimate result shows that the corn-based ethylene is about the same as the fossil fuel-based ethylene, which is the purple bar on the right. The different types of allocation show quite different results. There's a lot of uncertainty as well. That uncertainty is not associated with the allocation process, I'll just note. But only with the mass and energy allocation was it shown that the corn ethylene had less greenhouse gas emissions than the fossil ethylene. Variability and uncertainty are another critical thing for considering an LCA. So suppose I told you that there's a new fuel I've developed with 20% lower life cycle greenhouse gas emissions than gasoline. Is this going to be an exciting one to invest in? Should we immediately go to this? But what if rather than the prior statement, which reported a best estimate or value, you were presented with this figure? Would this change how you thought about the investment? This figure shows butanol from switchgrass, which is a biofuel feedstock. It's not a food crop, but a lignocellulosic feedstock. So the life cycle greenhouse gas emissions associated with the butanol production and its use in a motor vehicle are shown on the figure. And a Monte Carlo analysis was used to estimate the probability that the emissions would be at various levels. And then it's compared with a point estimate for gasoline. Now I could also look at the Monte Carlo distribution for the US gasoline. And that provides some additional information because often the baseline or reference product is only represented by a point estimate. And sometimes the uncertainty analysis is only done for the product of interest, in this case, the butanol. So there's considerable likelihood the butanol may be better than gasoline for greenhouse gas emissions, but also the opposite. So the 20% really didn't capture the full picture. So in the final section, with just a few minutes to go of my talk, I will just sort of go through a couple of examples related to the greenwashing and the 7 sins. This is a study from long ago where the state of California had an electric vehicle mandate that required 2% of model year 1998 cars to be zero emissions electric vehicles. This is related to the claim, the hidden trade-off, a claim that a product is green based on a narrow set of attributes without attention to other important environmental issues. So this car had no tailpipe emissions, but producing and recycling the batteries was shown in a life cycle-based study by my thesis advisor and some colleagues in a science paper of 1995. They showed that this model electric car, because it had a lead acid battery, would release 60 times more lead per kilometer as it was driven compared to a gasoline car burning leaded gasoline, which had been banned at the time. These results were vigorously disputed by the government of California and supporters of electric vehicles, but the results were ultimately vindicated. So sin of the no proof. If you don't have an LCA or other scientific proof of a green claim, then obviously there's no proof. There's also claims that are too broad or poorly defined. So renewable is not always better, and perhaps the not should be in big, bold letters. Depending on the inputs, the feedstock, how a bio-derived polymer is produced is going to have major impacts on the results. So throughout this presentation, as I've mentioned, I've focused very much on greenhouse gas emissions, but these are some of the other impacts of a life cycle assessment. This study looked at 12 different polymers 7 from fossil fuels, 4 from biological resources, which are the ones in the box at the bottom, the PLA and W. So the light green, dark green, blue, and light blue. And so in this study, the biopolymer production, some of them resulted in the highest impacts in 5 of the 10 categories, and higher impacts are worse. So taller bars are worse. 5 of the 10 categories: the ozone depletion, acidification, eutrophication, carcinogens, and ecotoxicity. Some of this was a result of fertilizer use. Some of it was attributed to sugarcane farming and the ethanol production in one case. And there's other reasons why these may not perform as well, even as for some categories, as fossil fuel derived polymers. So it's very critical to not just take renewable as a winning claim. There are certification-like images that aren't really valid: zero emission vehicles, no tailpipe emissions, but obviously not zero emissions from a life cycle perspective. There's also the sin of irrelevance. This is a really interesting example where people talk about food miles, like how far is food transported, particularly in a cold place like Canada, where we don't have fresh fruit and vegetables very much, except for greenhouses in the winter. But if we looked at eliminating the transport of food for 1 year, it has less impact on greenhouse gas emissions than shifting to a vegetarian meal 1 day per week. And then the sin of the lesser of two evils. So this example would be looking at electric versus gasoline personal vehicles. So the claim may be true, but it risks distracting the consumer from the greater environmental impacts of the product. So in this case, driving a vehicle at all has a lot of impacts on the environment, far more than going on the bus, where you're sharing that transport and space with many other people. So only looking at the benefits of an electric vehicle over a gasoline vehicle can be misleading. So the last sin of greenwashing was the sin of fibbing or lying. So that's a pretty obvious one. So I'll just finish up now to say that there's a lot of utility to LCA. As I showed, it can be potentially viewed as manipulating results if you select certain functional units or boundaries of systems. But there are these guidelines for LCA, and analysts know what a good LCA looks like. And the quality of LCAs has improved immensely over time. While LCA is very resource intensive, requires extensive reliable data, it involves trade-offs among the impacts, and as mentioned, it has subjective elements and aspects that are subjective with respect to the selection of data or modeling decisions. But LCA is critical to support green claims. It's a unique method, one of the only methods for considering all life cycle stages of a product. Studies can be done carefully and with great detail. We spend so much time going through details of our assumptions, the collection of our data, looking at uncertainty and scenarios and how those impact products. We aim to have transparent and complete documentation. Many of our recent studies, we have put our models and documentation on GitHub or other open source platforms. So all of this is becoming more and more common. So it's really critical to focus on the robustness of study assumptions and methods, and to look at the full life cycle of products to understand environmental impacts and to avoid greenwashing. Thank you very much. It's been a pleasure to be here, and I'd be pleased to take any questions in the remaining time.
For this insightful talk, Professor Heather. You may raise your hand if you'd like to ask directly. We could open your mic and camera, or you can use the Q&A in the chat or the chat itself. This has been great. This is my first time to learn about the 7 sins, and I'd like to ask you about, what do you think the most challenges individuals face, researchers and policymakers in avoiding greenwashing in these three categories? What's your insight on that?
I think that the complexity of the studies is really the challenge, because policymakers and others are often looking for a clear answer of which product is better or worse for the environment. And a lot of cases, it depends. And we need to look at the details of under what circumstances is a product better or worse for the environment. And because of the complexity of doing that and the complexity of communicating that, I think a lot of it is in the communication aspects.
Then if we would blame somebody, who should we blame?
I mean, I think that the blame can be shared in some ways. I think that that companies, years ago, not very many companies had life cycle experts employed within their companies. Some of the very large companies have always had those type of people, like very large automakers or chemicals companies. But more and more now, there are experts on life cycle assessment that are employed within companies. And so that these people can really ensure that the studies that they either do in-house or procure a consultant to do, that these are very high quality studies and that these studies are done appropriately. And so I think that no longer is it okay to sort of say, well, we didn't quite know what were the impacts. But of course, there are unknown impacts that sometimes you can find after the fact that something was not looked at. There also could be studies that are too narrow, focused only on greenhouse gas emissions, which is the most common metric, as I've said, to look at, or most common impact. So I think that also consumers need to really step up and be very, educate themselves as well. And particularly those of us in the sort of research environments, we have the ability to see the nuance and to ask the questions about products and to really look beyond fake logos or things like that. So, but great questions. Thank you, Emma.
Professor Tad Batsik would like to comment or ask a question. I think your mic is open.
Yeah. Right. Well, thank you, Heather, for a very interesting talk. I've been struggling with life cycle analysis for, I don't know, close to 20 years. And I recall at the very beginning, I got materials from two conferences in Stockholm. I think it was 1979, 76, which outline principles of life cycle analysis. And in the second conference, in fact, insisted on the use of free energy, as this is the only thing that matters, which is consumed, depleted, destroyed by various products or processes. And of course, I was one of the original two people, Pimentel and Pacek, who challenged the ethanol mania in 2004 with lots of difficulties that caused in my personal life. But after, thinking about this and doing these things for so many years, I really think that most life cycle analyses are far from clear. And that's because the boundaries used for this cycle analysis are incredibly influential for the results. But you need to stop somewhere. So A, complexity, B, even more complexity in using free energy that no one understands outside of very few people, and C, the problem with the boundaries. So how do you, my question to you is, how do you struggle with this personally then to communicate the message so that finally the public opinion changes? It takes, in my case, it took 9 years or 10 years to do that. But it's incredibly difficult. And for the students, I would add that the latest IPCC report with the whatever 50-page technical summary and then 30-page or so policy summary is essentially unreadable. The technical summary, you know, I'm a specialist who works in this, and I find it exceedingly difficult to get through the pages. For God's sake, these people should be taught how to communicate. So these are my thoughts and questions. How do we communicate? I think that is the most important part of what we do here.
Yeah, I thank you for those observations and also for the question. And I'm well aware of your work on the ethanol side. And the communication is very complicated. Most people underestimate the difficulties of doing the life cycle assessment work. This has improved, but there are still many people who underestimate the challenges and the difficulty in doing it and the nuance, which makes it more difficult to communicate the issues because sometimes this lack of understanding of the method itself and of the limitations of it. So I guess I always take a fairly conservative role in the communications that I try to explain, depending on the audience and their level of knowledge of life cycle assessment, the issues such as system boundary, implications of uncertainty and variability in the study. And I try to be as comprehensive as possible in doing the study, but then try to break it down into some key messages, but then also saying under these conditions, this product, you know, may be superior to the other for this particular metric, but we also need to be aware of these conditions where, you know, where the high carbon electricity generation is coming into play, or if we were to look at this metric instead of this one. And so I do, you know, I very much sympathize with this challenge, and you know, I'm still working on this, and I've been doing it for a while, but I'm still working on it, and still working on educating the audience as well about the challenges in life cycle assessment. But great points that you brought up.
Thank you.
Hello?
Hello?
Yes, we hear you. Yes.
Yeah. Especially, thank you very much, Heather, for the talk. Really insightful. I have one small question. You showed the cars operating on CNG, and that it has more CO2 per, I think, kilowatt hour. Which surprised me a little bit, knowing that the carbon intensity of methane is not that high. And I noticed that you do have a bar on top of it for the production sort of component. I wonder if you could answer that. And the second question is, if we want to sort of, obviously in a transition type period, and let's assume we're going to look ahead for the next 20, 30 years. And it's within this 20, 30 years, we want to increase, for example, the number of electric cars, because they do have a role to play in decarbonizing transport. So in your opinion, or has there been some work done in saying that as we decarbonizing the network and at the same time increasing the number of electric cars, then eventually at some point, these two curves are going to intersect, and electric vehicles will be better than sort of gasoline powered cars. While, for example, for heavy vehicles, it will never be, irrespective of what happens. Has there been sort of a timeline? Because I feel that most of the data you presented is at sort of a time where it has been produced. Today, there isn't enough renewable electricity for this to happen. But what happens in, say, 5 years' time? So I'm wondering if there's a timeline that one should also consider.
Yeah, so the CNG vehicle, Part of that is due to the heavy tanks that are required on the CNG vehicle, and the generally sort of that this increases the weight of the vehicle and therefore makes it less efficient. It also depends on the leakage rate of methane in the upstream process. And so because methane has a higher global warming potential than CO2, as you know, then if you get some leakage of the methane in the upstream process or from the vehicle itself, but more so in the upstream process. So it very much depends on the specifics of the CNG, the efficiency of that vehicle, and then where that CNG is coming from. So CNG, these are point estimates. So CNG can have a range as well, depending on vehicle fuel efficiency and assumptions about methane leakage upstream. With respect to the EVs versus gasoline, we have done quite a lot of work and are continuing our work looking at electric vehicles versus gasoline vehicles. And we've also created a life cycle-based fleet model for the US and for Canada, where we look at the penetration of electric vehicles in the fleet. How long would it take to get a certain proportion of electric vehicles into the fleet, and what would be the emissions reductions associated with those? Right now, over the lifetime of a vehicle, so taking account the full life cycle assessment, unless you have very high carbon electricity generation, such as some of the provinces in China, for example, or others that are very heavily coal dependent, unless you have that, you will generally get emissions reductions even now over the life cycle of vehicle, even with quite high GHG intensity electricity used in the vehicle over the lifetime, in spite of the emissions associated with the manufacture of the vehicle, particularly due to the battery representing a larger component than, say, a gasoline vehicle. But still, you would get emissions reductions even now. As these vehicles improve further and as grids become lower carbon, then you're going to get further improvements. But you do need to think about what materials will those batteries be made from in the future. Critical materials are something that will come up as key once you get more and more electric vehicles being produced and on the road. So I hope that responds to your question.
Thank you very much.
Wonderful. The last questions from Craig.
Hi, can you hear me?
Yes. Yeah.
Yes,
go ahead, Craig.
Thank you for the talk, Professor MacLean. I've got a question of labeling. What do you envisage will be the future of labeling, given the complexity of this issue and how that can be easily communicated visually on symbols on packaging, or any other way that this can be communicated?
What a great question. A tough one to end on, though. I was hoping you'd send an easy one my way.
I've got another one which might be tougher.
Labeling is not my strength,
okay.
But I mean, I do think a lot of people have thought of something similar to the food labeling, where they label percentage of salt and fats and things like that. I think that this is really something that we need to think about as a broad community, and as to what are some consistent ways to communicate the environmental performance of products. And the challenge is that we have so many different baselines sometimes, because something may look quite green when it's compared to a poor baseline, and then other times it may shift and not look very green when you compare it with something else. So I think that offers a challenge compared to some of the food types of labels. But great question. Thank you so much.
No problem. Yeah, it's just like a single unit or something that could have been done, but it's, as you say, it's very complex, and it's kind of building on Tad's question of, due to the nature of the complexity and the subjectiveness, means red tape is already an issue with many manufacturing processes. And like some cynical people might say that we're creating an expensive bureaucracy, ultimately where the cost of that bureaucracy is going to be passed on to the consumer. And that's a problem with any sustainability initiative. Often the impact is on the poorest people in the world. It's like, how can we simplify these processes so that we're not negatively affecting the people that it needs to benefit the most? I wonder if you have any opinions on.
The questions are getting harder, Craig. Yeah. I think we do need to simplify the process. I think we need to do the detailed studies, but I think we need to get the information out there in a clear and transparent way so that consumers can act on the information. If we confuse people entirely, they're not going to know which way to go. And I think that it's very critical that we figure out, you know, what are some of the critical metrics to look at, and how do we convey this information to consumers? And are there certain things that should be looked out for and certain things that really should be pushed back about? So I know that some of the UK is looking at sort of the fast fashion industry in detail. So there may be some sectors where we really should be putting a big push on some of the communication ahead of some of the others, some of the ones where really consumers could be affected and make decisions about their choices.
Excellent, thank you.
Thank you so much. Our event came to an end. It was a really wonderful evening with Professor Heather. Thanks for all the great questions and great answers. And we would love to thank you with symbolic gifts from Students for Sustainability and KAUST. We're gonna we usually give, we started giving our speakers a glass homemade memorial gift, so customized with your name here in our labs. So it's going to be our pleasure to ship it to your office in Canada. Although that would, but shipment is not as bad by ships as flights. So hopefully it's worth it, right? And thank you so much. Any just final thoughts about, have you ever thought of the role of AI in the life cycle assessments? Maybe that could advance it a lot using artificial intelligence.
I think that's a great thought. As long as we have the data to support that, or methods to have low data requirements, because sometimes we're struggling for the data, but it's a great ending thought. And it was my pleasure to be here, and thank you for the great questions, and I look forward to the shipment. So thank you.
Yes, have a lovely night.